Okay, this is Mr. Great here in Mr. Great Tech Review Studio, bringing you technological updates. I'm here once again with our most excellent Arduino tutorial. But today we are going to digress a little bit to discuss about power supply and how you can get a very good power supply from your old desktop or tower computer. Now, we know that technology is advancing, and during those days I first purchased my first computer. That should be Pentium 2, and you have a power supply in that Pentium 2 that is ATX, which is Advanced Technology Extended Power Supply. I think that is the meaning, Advanced Technology Extended Power Supply, ATX power supplies. And in that computer you have the hard drive, the floppy disk, we have CD-ROM, DVD, depending on the type. You have CD-ROM writable, CD-ROM writer, and rest of them inside those Pentium computers, Pentium 1, Pentium 2, Pentium 3, Pentium M, desktop or tower computer. Then and the power supply is very, very important. There's not, if God blesses you, you get a laptop and you discard the computer, and without knowing that there is very important aspect of that computer that is still valid up to today, and it's very good components in that computer. The power supply is very, very important. In today's electronics, we make use of 5 volts, 3 volts, 12 volts supply system. Sometimes we go and purchase power modules to power our projects or to power our panels and the relays and the electronics inside our panels. And sometimes we find out that we purchase these items very costly and very expensive. They are very expensive. Those power supplies are very expensive. You have a Yamaha keyboard, you have your keyboard power brick you differently, and you have also other equipment that has a power brick differently. They are not included in the device. So such power supply will be very, very useful to you, and also very, very useful to all of us in this tutorial class. And I want you to go and look for it in your old computer. You will see it there, the ATX power supply. Time will not permit me to talk about the AT power supply, but from 1999 upwards, you have ATX power supply in your system, and we are going to dissect the ATX power supply and to know how we can make use of it, how we can start it up, because now you are not using it inside the computer, you are bringing it out from the computer, and you are going to use it for a different project, and you are going to use it for yourself. You can use it to charge your phone, you can use it to power your keyboard, use the 12 volts. 12 volts works, most of the Yamaha PSR keyboard works with 12 volts power supply, and some relays and timers work with 12 volts power supply. And what again, 5 volts is there. You can use it to power and charge your phone, and you can charge up to 10 phones at the same time with one power supply. Can work, because by the time we look at it and we see that some of them has a current capacity of 18 amps, and most of your charger has 2 amps. So you find out that 2 times 10 is what, 20. So 18, 9 to 8 phones can charge at the same time with such a power supply. And depending on how you arrange it, if you arrange it very well, you can use it like that. So we are going to see how we can salvage our old system and make use of it. And okay, so I'm going to do that. And show you where I got the power supply and how you can bring it out from your tower, your old system that you are not using again. Don't go and baccanize a system that is still functioning, and just an old stuff in your junkyard. You can get such power supply from there, and it will serve you both in your Raspberry Pi project, your Arduino project, and every other project you are doing in electronics and electrical electronics, in your panels, and every other project that requires 5 volts, 3 volts, 12 volts. And you find out that this power supply is regulated, is very good, and it's advanced, just like advanced technology extended power supply according to the name. Okay, so now let's see and how we can okay, advanced technology extended power supply. Okay, so let's go and see the pinout configuration. And first of all, let me show you this power supply and how it looks and how you can make the maximum use of it, and also I've told you where you can get it. Okay, so let's see. I have it here. Okay, very good. So this is it. This is the computer power supply. This is what you will find inside your old desktop computer or your tower computer, old desktop Pentium 1, Pentium 2, Pentium 3, Pentium 4, Pentium Millennium computers that makes use of Windows XP, Windows 95, the rest of them. This is what you will get from it. Okay, so let's look at it and see how and what this one is all about, and the capacity. This is Dell. Okay, let me come very close so that we can see. Okay, so this is Dell, and they say the maximum power is what, 20 or 250 watts, and this is two and the input voltage is 100 to 120 volts by 9 amperes, what is consuming from your main supply, or 200 to 240 by 4.5 amperes, and you have a 5 volts DC supply, that is the output section, which is 22 amps, so you can charge up to 10 phones at the same time. That makes use of 22 amps power supply. Okay, and they have a 12 volts 16 amps, 12 volts 16 amps. Then keyboard is around 4 amps and the rest of that. So 16 divided by 4, you find that it can power up to 4 keyboards at the same time. Okay, and they also 5 volts on standby mode, which is standby mode. I will show you the standby mode power supply. That is differently. You have 2 amps, and you have also minus 12 volts here. You have minus 12 volts here, and that minus 12 volts is what you have by 1 amp. We are not making use of that. And you have also plus 3 volts, which is 18 amps. For you can use this plus 3 volts to power your Raspberry Pi that makes use of 3 volts. And that is it. Okay, so that is it, and that is the power breakdown of this ATX power supply. Okay, so now here you have the fan. You have the fan here. This is the fan. Okay, and you have the input where you put your power cable. Put your power cable here. Put your power cable here, and you have your selector switch. Yeah, in Nigeria we're making use of 230, so it's on 230. You can also switch it if your power supply is 115 volts and 120, 115, 110 volts. You can switch it here, but be very careful with this. If you're on 230 and switch to 115 volts, you are going to damage your power supply. Okay, so that is it for this. And then you have the pinouts, the cable pinout, and okay, so you have the pinouts. So this is the cable, this is the pinout, this is the wire that comes out of it. It's confusing, but I will break all of them down. All the blacks are words, all the blacks are ground, all the blacks are ground, so the blacks are the same thing. And all the yellow volts, all the yellow wires are words are 12 volts. All the yellow wires are 12 volts, all the yellow wires are 12 volts. Any place you see yellow wire is 12 volts. So I'm gonna break it down. You find out that it's not difficult, it's not complex. See all of that, all of these yellow wires. Any place you see yellow, it is what, plus 12 volts, and any place you see red is what, plus 5 volts. So all the red here are plus 5 volts, plus 5 volts here. These are plus 5 volts. And the orange is plus 3 votes. All the orange, they are plus 3 votes. The orange are plus 3 votes. All the orange are plus 3 votes combined together, plus one tiny brown, that is plus 3 votes. That tiny brown is, you have to loop it up. Okay, it's already connected to the yellow pin, but if it is not connected in some system, you have to twist it with the orange, so that you have a steady supply of your power supply in this. And then okay, so what again? The black is the ground, the yellow is the 12 votes, the red is the plus 5 votes, and the orange is what? The plus 3 votes. Okay, now let's come to the awkward ones that looks awkward. Okay, let me explain these ones. And okay, so you have the green. The green pin is power supply on. What it means is that this green pin, this green wire, combine it with the black wire, you start up what? You start up the power supply. You start it up. So if you want to power this power supply, if you on it, it will be on standby mode. On that standby mode, what you will have is only voltage plus 5 volts from this purple. On standby mode, as you plug it on the power in the main supply, you already have 5 volts here with the ground. You have 5 volts here with this ground. The purple, we have 5 volts here. You have purple, you have 5 volts. And this purple is on the standby mode. On the standby mode, we have this. So when you bridge this and this, when you bridge the green and the black, then you power it on. When you power it on, then you have voltage across the lines. You have the voltage across the yellow, the orange, and the red. You have voltage across all of them, including the standby pin, the standby wire. Okay, including the standby wire, which is what? The purple. Okay, and so we have for the ATX, this is for 20 pin ATX power supply. The 20 pin ATX power supply, have the 20 pin, have the 24 pin, that is that have the 2.2, which is 24, but this is 20 pin. Okay, so now let's what again is remaining there? Okay, then they have the blue wire. That the blue wire is what? The blue wire is minus 12 volts. The blue wire gives you minus 12 volts. The blue wire gives you minus 12 volts. With the ground, you have minus 12 volts on the blue wire. And what is remaining again? Okay, the gray. You have the gray wire is power good. That means it's going to give you what? The gray wire is going to give you power good. Gray wire is going to give you 5 volts, and that 5 volts, and then okay, just like I said, you have the gray wire, which is the power good. The gray wire is the power good. That means you connect your LED here, your green LED. Immediately you switch it on by combining the green and the black wire. Power comes to this place to power your LED, to show that the power is good. Everything is okay. All things being equal, ceteris paribus, you have a 5 volts here. It shows that the power is good. So that is the function of this gray wire. Okay, so that is it, and okay, so we can now go to, let's also go to Google so that we can see the configuration here. And then you have here, we have, like I just told you, all the yellow, the orange is what? Plus 3 volts. The blacks are common, they are ground, and the red, you have what? You have your 5 volts here, and you have a black common. Then you have a standby mode, purple, 5 volts. Then you have the yellow pins, and they are 12 volts. And you have like I said, the orange is 3 volts, the black is common. Okay, what again you have here? And the white not connected, you don't have it. Okay, PS on, power on, which is the green, combination of bridging the green and the black. The green and the black, you have power you powered your power supply. And minus 12 volts, you have what? You have the blue as a minus 12 volts. And the same thing applies here in 20 pin connection, and this is 24 pin connection, and this is 20 pin connection. So the same thing applies in this place, and that is it for the ATX power supply pinout diagram. Okay, so and okay, I don't have much. Okay, so the same thing here, you can see it from Google. You go and browse, and you get your pinout configuration. If you are still confused about the pinout reference configuration for ATS 2024 volt 24 pin connectors. Okay, so that is it. Okay, now so let's go and see how we can power it, and what we can construct out of it, and how we can use our brain, and what we can cut off and what we don't need. Okay, so these are the connections, these are the connectors, and okay, so these are different types. You go to Google, you can see different types of ATX, and this is computer where it's been located, and that is it. Okay, so now, okay, we are good. Okay, so that is it, and we are here once again, bringing you the most advanced technological updates on our ATX power supply, how we can salvage, how we can make use of our abandoned ATX power supply from our abandoned desktop computer, and what it can do for us. And that is it. And here I have a way that I figured it out to make use of this power supply to benefit me, and I'm going to show you the construction and how we are going to do it. Okay, let me keep this one here. Okay, so and okay, so now this camera is going to pick this out. This is the way I plan to route my connections. Very simple. Okay, I will show you the physical, what I plan doing with it. Okay, so this is it. This is the way I plan to use it. See it? Good. This is the way I plan to use it. I use a Dignity box, and I plan to combine it this way, and here I make my connections. So this place, I have my first 12 volts, my 5 volts, my 3 volts goes down here, and here I have my 12 volts 1, 2. I will make use of it as I will route 12 volts here. I'll route my 5 volts here. 2 of them will be 5 volts for 5 volts supply, and here I will make this one will be my 12 volts, another 12 volts, and another 12 volts, and okay, I'll make it, maybe I'll do 12 volts, 6 volts, 12 volts, 5 volts, and 3 volts from here. So this and this should be 12 volts, this and this should be 5 volts, and this will be 3 volts, and this 12 volts, and this will be 5 volts. And here is where I'll connect my power on switch. That means the green and the black, we combine them together in this switch. So I have this as my standby mode LED, and this as my power on LED. And that is it. Any other extra protection, maybe my fuse and every other thing. Okay, now also route a 5 volts. I did something like this. I make use of my old charger that I'm not making use of, and I cut it. I removed this and this is how I do it. So that one I'll put it here. I'll route it from here. So it looks like this. It's going to look like this. So I'm going to make use of this. I connect my USB to USB port here. I'll connect to USB port here for charging of my phones, and these ones I write it out for my practicals, my electronics practicals, my Arduino practicals, and every other electronic practicals. And this place is I will use to power maybe keyboard. I like playing keyboard. I will use this one for my keyboard, and this one for any other 5 volt supply that I can still route out from here. But these two specifically 12 volts, I'll use it for my keyboard. My 2 keyboard, we'll route it here. So that is it. So in laboratory I can make use of it. Domestically I can make use of it. So it's having 2 purposes for me. In the lab, in the electronic lab, I'll make use of it for my practicals, to power my relays, my timer, like I have my timer here with me. So like I have this timer here. So this timer is what? This timer is let's come very close and see what this timer is. What this timer is 12 volts to 220 volts AC DC combination. So it's end-test timer. Whenever you are doing practicals and you are working on electrical panels, try as much as you can to make use of this multi-purpose timer. So since it's 12 volts, so I can also use it to power this. And they have my Shirac relay here, which is what okay, this is 24 volts, but I have 12 volts of it. I can also route it here and use it to supply in case I have such a project that I'm going to make use of these relays. I can also take power from here. Just know this is a power pack. I can make use of it in my 24 volts, 5 volts, and 3 volts power supply system. And they have my amperage, and they have on the 12 volts we have 16 amps, and on my 5 volts I have 22 amps. On my 3 volt supply I have 18 amps. So I have a very good wide range of amperage to work with. So that is this. Okay, now the inside, this is how it looks like I showed you, and this is where I'll make my connections. And okay, I can also add a fuse for the 3 volts, 5 volts, and the 12 volts. I can for protection in case of short circuit, and the fuse we cut, and these pins are for this one is for this, for laboratory purpose, and okay, so, and that is it. And this is a circuit breaker, but I'm not gonna make use of it. Okay, and this is my LED I'm going to use. This is empty, and okay, so this is empty. You can see it's empty. I can put my LED inside, and the longer leg is the positive, the cathode, and the shorter leg is what? The anode. So this is it, and okay, so this is it. Okay, and the same thing with the green LED, goes like this. So I can remove this, I can slot it in here, slot it in here, and okay, so, and they have what, your 220 ohms or anything from 100 to 470 ohms resistor. Remember, you are going to hook up this green pin and the standby, and which is what the standby is, what the standby is a purple, which is standby, the purple, Where is the purple here? Okay. Okay, so this is the purple, which is the standby, which is we are going to hook up this plus one of the ground, hook up it via the resistor, the 220 ohms, 470 ohms, 330 ohms, or 100 ohms resistor. You can make use of such resistors, and my 5 volts will go to this place for charging of my phone. You have your iPhones, your Samsung, and any other phone, and you can route it out here. Just like I told you, one of my spoiled charger, I have to break it and bring out this, and this is how I'm going to hook it up. Okay, look at it here, and I will use my glue gun to hook it up, and I'll route my connections. I'm just giving you this idea so that you can also improve on it and bring out a better option. Okay, so that is it. That's how I'm going to hook it up, and it's gonna be here. It's going to be here. It's going to be here. Okay, so I will use my glue gun to hook it up and make some soldering from here, and so that these ones, and that is it. And that is how I'm going to make use of my 80H power supply for myself, and for domestic, and also for laboratory purpose. Okay, so that is it. Next other one, we're going to go to the workshop to hook it up and hook all those things up and see and power it and see how it's going to benefit us. Okay, so that is it. And before I leave, I'm gonna power it. I'm going to power it when I power it, and I'm going to show you. Okay, because it's bridged together already. This is it, it's already bridged together. So if I power it, it's going to come on immediately, and you have voltages on this. You have, just like I told you, this is 3 volts, this is 12 volts, this is 5 volts. Okay, so this is it, and they have here 3 volts, 12 volts, 5 volts. So that is it. So no need. And okay, let me just power it. Okay, see the fan is blowing, and that is it. Let's use our meter to check our voltage. Switch to DC. Okay, okay, this is my ground. I have my ground. I hook it up with what? I hook it up with the green to power the LED, to power the power pack. So now I'm going to text these ones one after the other, and you are going to look at the meter to see. Okay, so I have the first one, which is the red. I have my red. So okay, I have my red. This is 5 volts. Then I have my orange. Sorry, my yellow. 11.6. Okay, 11.6. And I have my orange. I have 3.3 volts. Okay, so that is it. Oh, once again, there is something I'm forgetting. Thank God that I remember it. If you, some power supplies, you need a load resistor, which is what, 40 to 50 ohms, 5 watts power resistor, just to act as a dummy load. And I think I have it here. I don't have it here. So what we are going to do is that you pick up one 5 volt supply, which is what, one red. Pick up one red. pick up one red, let's say like this. Pick up one red, then you pick up one black, you pick up one black like this, and you put a resistor in between the red and the black. This is 40 something ohms, 47 ohms resistor, 47 ohms resistor, 20 watts, 10 watts resistor. That these are dummy resistors, just to act as a load to stabilize the voltage, so that you have a stable voltage in the power supply. So that's what you're going to do in some of them, so that it's going to function and work very well. So if your own is not working very well, this is what you're going to do. You put a resistor in between the 5 volts, one of the 5 volts, and the what, and the ground. So, and it's not going to get too much hot, and you can glue it to the casing of what, of the power supply, so that the casing will act as a heat sink for the resistor. Remember, I said 10 to 20 watts, 47 ohms or 50 ohms power resistor, choke resistor. So to act as a dummy load, just to act as a dummy load to stabilize the power supply, so that you can have voltages in the 12 volts, 5 volts, and 3 volts supply outlets. So that is what you are going to do. If your own works like that, you do it. If your own doesn't work like that, there's no need adding the dummy resistor for the power supply. Okay, thank you very much, and for now we have to go to the workshop, so that we can couple these things up, and we'll bring it back, and we test, and we power our keyboard, we power our phones, and also we can use it to power our Arduino and other things we can hook up to the power supply. So this is how you can salvage, this is how you can make use of your 88 power supply. Go and look for your old desktop computer, and you get your 80x power supply out of it, and use this method, so that we can make use of it, and you find out that it's useful, it's still useful, and it's going to help you. You are going to save cost. And purchasing this power supply alone in the market has to cost you a lot of money. But now, making use of your simple common sense, you are putting it into work, you find out that you can still make use of it, you can still save costs. That is it. Thank you very much, and let's go to the workshop. Okay, welcome back from the workshop. We are here back again in the studio to explain what we have done in the workshop concerning our ATS regulated power supply. Okay, now I have my advanced technology extended power supply, which I have converted to suit my demand, my power demand, as you can see. Here is it. Okay, good. And this is the raw form. This is how it is. There's another one. Okay, this is the 20 pin connector for your motherboard in the system. Okay, so that you can see it. Okay, I have explained the routing and how this stuff work. Okay, I have, just like I said, I'm much concerned about the amperage, because that is what determines what the capacity of this power supply, power pack, 250 watt maximum output power can deliver. But that did not actually explain, the capacity 250 watts. Somebody, how do you relate it to, to devices hooked up in this stuff like this? So now we say 2 amps, 3 amps, 4 amps, power pack, power break. It's more understandable. It can make more sense than saying totally 250 watts. Okay, so now I have, just like I told you, I have my 5 volts supply from this. These are my 5 volts. I have my 5 volts. I hooked up my 2 phones. This is my Infinix, and this is my Samsung, and they are charging. Okay, let me. Okay, you can see it's charging. That is it. Hooked up. Hooked up. Look at it here, hooked up. It's charging. Okay, I can off. You can see my phone will change. I can on it. You can see it. Okay, and you observe something. When I off it, the standby light is on. When I on it, that is bridging the violet, the green and the black bridge together, turns it on from the configuration I showed you earlier. Okay, so that is it. So now same thing with Samsung. Same thing with my Samsung. I off it, I on it back. You see it? Okay, starts charging. Okay, so that is it. That is one aspect of it. That is the domestic aspect of it. And okay, let's go to the laboratory and see what we can use it to do. Just like you see my peanuts, these are my peanuts. I have my 12 volts, my 5 volts, my 3 volts here. All these, let me, so that you can see what I'm saying. So this is my 12 volts, this is my 5 volts, this is my 3 volts, and this is for my phone, my tablet, or anything that has to do with 5 volt supply. Even tablet, PC can charge, because the power output says 5 volts is what? 22 amps. 22 watt amps. That's what it says. So 5 volts is 22 amps. So this 5 volts here is 22 amps. The summation of the whole 5 volts here is 22 amps here. So 22 amps can charge up to 8 phones at the same time without damaging the power system, the power pack. Okay, so now let's go to here, this terminal block. I have my first one here. I have not labeled all these things. I will still label it so that it will look nice and look decent. Okay, so this is 5 volts. This is fresh from the workshop. I have not labeled it. Okay, this is 12 volts. This is 5 volts in the middle, and 3 volts last for your Raspberry Pi project. Okay, another thing is I need 3 volts supply. Okay, I think light emitting diode works well with 3 volts. I think if I put light emitting diode here, I will have power. I think so. Light emitting diodes. My first leg is what? Positive. My second leg is what? Negative. And okay. To flash it, I need to add a resistor for us to. Okay, let me. Okay, use my meter so that I can show you how it works. Okay, this is the meter. Okay, so let me switch to voltage range. Then this is what you have. 3.3 volts. You have 3.3 volts. You have 5 volts, and you have 12 volts. I have 12 volts. I have my phone hooked up now. It's 12 volts. It's balanced now. On the 5 volt side, I have my phone hooked up. Okay, so let me remove this phone. Remove this phone. You find out that this is where you need a load resistor. You see, it's 11 point what? 11.7. So if I plug any of this phone, you have what? 12 volts. So it's now balanced because I have a load on the 5 volts. That is what the load resistor, the dummy resistor, does for you. So if you add the dummy resistor, it will help to balance the power supply. Okay, so that is it. Okay, so it's balanced. It's balanced. It's balanced. 5 volts. And this is 3 volts. So the same thing applies here. The same thing applies here. You have your 12 volts. This one, you have your 5 volts. And this place, you have a 3.3 volts. Okay, so that is it. And that is all for now. So that is how you can make use of this power supply. As you can see, the fan is turning. If I put it off, the fan goes off. Yes, the fan goes off. You can see it. Turn it on, the fan comes on, my phone comes on. That is it. Okay, so that is it. This is what it is, and that is it. Okay, so bye bye for now. I'm Mr. Great here in Mr. Great Tech Review Studio, bringing you tech updates. Okay, once again, I'm out of here. And I encourage you to share and like this video. I hope it makes sense to you. And I will encourage you to join me in my next class on understanding how you can use RGB on your Arduino project. That should be tutorial number 25. This is a bonus tutorial on power supply, so that by the time you finish your Arduino, you can use this and to power your Arduino and the other Arduino related projects. You can use this power supply as your workshop bench power supply, regulated, purely regulated, standard, just like the name appears, advanced technology, extended power supply. Advanced technology, advanced is more advanced. The power supply that computer uses, you know how advanced it is. So it's purely regulated, free from ripples, free from noise, free from interference, and the frequency is purely 0. So that is it. DC 0 frequency. Okay, so that is it. I love this power supply. It's good. It's good and it's good and it's good. Okay. So like and share this video. I hope this video makes sense to you. I'm out of here. One and only Mr. Great here in Mr. Great Tech Review Studio. Bye bye for now. Okay.